Hello, my dear students. Today we are going to continue our lessons by learning how to separate the mixtures. We learned what is a mixture, what is a solution, how they are related, and how we can make a mixture or solution until now. So now we will learn how to separate the mixtures into their ingredients again. So if you want to just separate, let's say, the salad that we made, we just can pick each ingredients by looking, right? But for some other mixtures it may be harder to separate them to their ingredients, so we will see different methods to separate the mixtures today. If you want to follow me from your books, please open page 618 and 619. If you are ready, we will start. So we have basically 6 main techniques for separating mixtures. I will explain each of them in detail, but first I would like to name all of them. So we can separate mixtures by considering the density of ingredients. We can separate mixtures with using the state of ingredients, like for example, one ingredient can be a solid, one of them can be a liquid, so it may help us for separation. We can use a sieve or mesh. We can use the magnetic forces, the magnetism. We can use filtration, or we can use evaporation or boiling. We will discuss each of them in detail now. If you open your book, you will see on the first page, on page 618, our first example is related with density. So we discussed the density in our previous lessons. We discussed what is mass, what is volume, and what is density, remember? So each substance has a unique density. From water to glass to wood, all of them has density. So if something is less dense than the other, it can float on a denser substance. What does it mean? For example, like in this picture we have this corks, okay, and marbles. Marbles are made up of glass, okay, but cork is made up of a less dense material. When we put this cork and marble mixture into water, the marbles will sink while the corks will float. So it will give us a chance to separate these mixtures from each other. You can try this with different ingredients. You may see that some of them are some of the substances will be able to sink in the water, but some of them will sink on the water. Will float on the water. So it will mean that density of these substances may help you to separate them from each other. So you will see another example here in your book. Let me show it to you. It is using the marbles and some blocks, maybe toy blocks. So when you look at these tray, you can see that there is also some property used to separate this mixture. What can be this property to separate these marbles from these blocks? We can basically say that their shape is a really helpful property to separate these marbles from the blocks, because the marbles are circular, they will roll over to the tray, but the blocks will stay where they are. So we will be able to separate these two from each other. On the other hand, separating mixtures will not be that much easy every time. Imagine that you have a sand and water mixture. So you have a glass of water and you are putting sand inside this water. You will see sand will turn into sand will get wet, and it will be really, because it has small particles, it will be really hard for you to take all these particles from water one by one. So what can you use? You can use the material state, because one of them is in form of liquid while the other is solid, and a liquid will tend to go down from the mesh, like you see in this picture. If we have a mesh or sieve like here, you will be able to separate this mixture, the sand, from water easily. What about the size? So if you have different solids with different sizes, again you can use a sieve or mesh with bigger pores to separate different sizes of solid. So, and it may also help you to separate them manually with your hand. So size is also an important property for separating the mixtures. What else? We have shapes of different substances. So you can separate the solid parts of a mixture based on the shape of different parts. You can separate the circular ones and the rectangular ones by using the shape, what we discussed on our example here. Also, what we say for this example, we also say that shape is an important property for separating the mixtures, right? The color of the solid parts of a mixture can also be used to separate the different parts. You can use different colors. You can choose the same color from this mixture. For example, you can just select the green ones first and the red ones first, and you can just easily separate this mixture to their ingredients. And something really enjoying is the magnetism. So magnetism will be really helpful for you to separate some important mixtures. Some materials, like iron for example, are magnetic. So you can use magnets to separate magnetic and non-magnetic materials in a mixture. What we see here actually is how a giant magnet is pulling off the iron material, magnetic material, in a garbage. In your book you will also see another type of separation, which is called filtration here. So how filtration works? Remember the mesh that we discussed for the first place? So if you are dealing with smaller particles, if you are trying to separate smaller particles, like for example coffee, you can use filter paper, and this filter paper will when the water will filter the water and just removes the soil, removes the coffee, or in this example removes the soil from water. So another important thing related with separation of a mixture. So we say that we can separate mixtures that easily if we are able to see the ingredients of this mixture. But in solutions, as you know, solutions are also mixtures, but we cannot see the ingredients inside a solution. So how we are going to separate the ingredients of a solution. If you are dealing with a sugar water solution or salt water solution, we have a really easy way to separate these into ingredients. Solutions like salt water can be separated by boiling. So the water evaporates after boiling, but the salt will left behind. And you will be able to take the salt particles as a precipitate from the water. So this will help you to separate the ingredients of the solutions. Now let's try to solve an example. So we are going to match each mixture with the word that describes the best way to separate it. Okay, what we have here: a salt water, metal trash, water and soil mixture, and salad dressing, like with different spices and oil. So what can we do to separate these mixtures? Salt water is a mixture which is also a solution. So what we gave example to solutions just before, we can separate the solutions by evaporation. Let's try if it is correct. Yes, perfect. So metal trash. Remember the magnetism. Like I said, some metals are magnetic, so we can use magnetic force, a magnet, to separate this metal trash from the other trash. What else? We have water and soil. Do you remember any example related with water and soil that we discussed before? Perfect, filtration. So we can use a filter paper for separating water and soil. For salad dressing, it is a mixture of lemon juice, probably oil and other spices, which have different densities. So we can use the density, the factor of density, which can be also considered as floating and sinking, the first thing that I explained to you, to separate the salad dressing. So mixtures can be separated by using floating and sinking, by filtrating, by magnetic force or evaporation, or the other properties like shape, color, and state that I explained to you before. So because materials have different properties, the best way to separate one mixture is not always the best way to separate a different mixture. Don't forget, each mixture will need a different way for separation. Let's try to solve another example. This is a more complex one. So we have a mixture of salt and sand. How will you going to separate this mixture? Try to remember each of these techniques that we discussed. So you can use more than one technique, by the way. How will you going to separate this mixture into their ingredients? Because salt and sand both has really small particles. So think a little bit, then please continue the video after your guess. So if you put the salt and sand mixture into water, what will you expect? Salt will dissolve, but sand will remain as solid. It will not dissolve. What we learned? We can separate sand from water by using a mesh or by using a filter paper. So if I use a filter paper to separate this salt, sand, and water mixture. What will I have? I will be able to separate the salt, and as a result I will have a salt-water mixture. So what will you going to do with the salt-water mixture? We can also boil the water and with evaporation separate the salt from water. So for this, what we used, first we used filtration and then we used evaporation to separate the salt and sand from each other. Okay, let's check what we covered until now about mixtures and solutions. Our last lesson and our previous lessons on the class. So the combined parts of a mixture keep their own properties. Don't forget that in a salad, because they are mixed, the taste of tomato and the carrot will not change. They will keep their own properties. This is not a chemical change, this is a physical change. Okay, mixing different substances is considered as a physical change. Okay, so because of this, the combined parts of a mixture will keep their own properties. A solution is a mixture with the same properties throughout. What we said about solutions, they are also mixtures, but they should have the same properties like taste, like appearance, okay, like color. So we are expecting a solution to have the same properties throughout the mixture. Okay, so what we learned yesterday, stirring, heating, or using smaller particles can increase the speed of dissolving. Okay, if you tried the experiment on our last session, you also tried it, solve it by yourself. And physical properties like size, shape, color can be used to separate parts of a mixture. Also, we know that density can be used to separate the parts of a mixture. Magnetism can be used to separate the parts of a mixture. The state of materials can be used to separate the parts of a mixture. And the particle size, like for filtration, can be used to separate the parts of a mixture. Okay, so that's all for today. Now with this subject we finished our subject related with mixtures and solutions. So please go to pages 622, 623, 624 and 625 to do your homework. Okay, do these activities on these pages to understand this topic better. If you have any questions, you can just go refer back to the previous pages to understand this subject more. Thank you very much for listening. I hope that you are all comfortable and ready for your homework. See you soon.